Morning, students. This is a chemistry unit for the third year students. The unit code is SCH3302, the chemistry of non-benzenoid aromatic compounds. And my name is Dr. Eunuce Marete. I'll be taking you through this unit. The photograph here you see is a plant. It's just a fennel plant. It's called a fennel plant, an aromatic herb that is used in cooking. To give you a course outline, we'll look at the non-aromatic and anti-aromatic compounds. We'll look at the Haeckel rule, that is the 4n+2, the anilines, which is the origin of their aromaticity and their synthesis and properties, and then look at the nomenclature, the structure, stability, synthesis, and reactions of naphthalene, anthracene, and phenanthrene. Then we look at the quinones and their use as oxidizing agent, optical activity due to restricted rotation of some biphenyls, properties, reactions, and synthesis of furan, thiophene, pyrrole, pyridine, and the origin of their aromaticity. These are some of the reference books that you can use. I'll not go through all of them. And next here, we'll just start by looking at aromaticity, which is the Haeckel's rule. So what is this aromaticity? Or when do we say that a compound is aromatic? Or when do we say that a compound has aromaticity properties? Now, the Haeckel's rule is commonly used to determine aromaticity and anti-aromaticity. Just to highlight here, aromaticity and anti-aromaticity. And the simplest aromatic hydrocarbon is the benzene. A benzene is a 6-membered ring, and it has 3 pi bonds of benzene comprising of single functional groups. So basically, we have a compound like this. This is a benzene compound. That is how a benzene compound looks like. And there are 4 structural criteria that must be satisfied for a compound to be aromatic. One of them is a molecule must be cyclic, it must be planar, it must be completely conjugated, and contain a particular number of the pi electrons. So I want you to remember that structure of benzene as we look through at the compounds that are found or that are said to be aromatic using this Haeckel's rule. Now, one of the criteria that must be met for a compound to be aromatic is a molecule must be cyclic, whereby each p orbital must overlap with the p orbitals on 2 adjacent atoms. Remember the molecule that we've just looked at, which is benzene. Now, the p orbitals on all 6 carbons of benzene continuously overlap. So benzene is aromatic. When you look at another molecule that is 1,3,5-hexatriene, it has 6 p orbitals too, but the 2 on the terminal carbons cannot overlap with each other. So 1,3,5-hexatriene is not aromatic. How does the 1,6,3,5-hexatriene look like? This is the structure of the 1,3,6,5-hexatriene. So we have the 1,3. This is a molecule that has 6 carbon atoms. So we have 1, 2, 3, 4, 5, and 6. So at carbon number 1, there is a double bond. At carbon number 3, there is another double bond. At carbon number 5, there is another double bond. But this molecule is not cyclic. As you can see, there is no overlap between the 1st carbon atom and the 6th carbon atom. The next one, the criteria that we look at next, yes, you can see that a cyclic compound, looking at benzene, and an acyclic compound, looking at the 1,3,5-hexatriene. These 2 do not overlap, so there's no overlap there. So this compound is said to be not aromatic.